So different substances require different amounts of heat to be added in order to change their temperature. When we add heat to a substance, it's adding energy. So it makes the little particles which make up the substance vibrate more. And temperature is actually defined as the internal kinetic energy of the substance. So as we add that energy, it does actually cause the temperature to increase. Now imagine that we had a wooden object and a metal object in the sun on a hot day. If you left them for the same amount of time and then went to touch them, the metal object would be a lot hotter than the wooden object, and not just because it's better at conducting heat. It also increases its temperature a lot more with the same amount of energy added to it. So the amount of energy you need to add to raise 1 kilogram of a substance 1 degrees Celsius or 1 degrees Kelvin, that's equivalent, is called the specific heat of that material. So wood has a much higher specific heat than metal. You need to add a lot more energy to wood to increase its temperature than you do to metal. So aluminium, for example, has a specific heat of around about 900 joules per Kelvin per kilogram. Wood is around about 1,700 joules per kelvins per kilograms. Now we're very lucky. Water actually has a very, very large specific heat compared to most substances. The specific heat of water is 4,186 joules per kelvins per kilograms. And why this is lucky is because a lot of the Earth's surface is covered by water. This means, because of the large specific heat, we need to put in a lot of energy into the water to change its temperature. So this large specific heat actually helps to mitigate global warming. When we add heat to the ocean, we have to add a lot of heat to change its temperature.
Now we're very lucky to live in coastal regions like Sydney because we have the ocean right next to us. Now the ocean can absorb a lot of heat with a very small change in temperature. And this helps to minimize temperature changes. When it's a hot day, the ocean absorbs a lot of heat and doesn't change its temperature very much. When it's a cool evening, the ocean releases a lot of heat without changing its temperature very much. In desert regions like Alice Springs, on the other hand, when it's a hot day, you're surrounded by sand, which is basically silicon dioxide, instead of by water. The specific heat of silicon dioxide is more like 1,000 joules per kilogram per Kelvin as opposed to 4,186 for water. So in the desert, the temperature of the sand changes a lot more in the day. The temperature will increase a lot more. And overnight, when it's cold, the temperature of the sand also changes a lot more rapidly. So it cools down a lot more quickly. And this is why you get such extreme temperature swings in the desert.
The land-to-water ratio in the northern hemisphere is much higher than in the southern hemisphere. In the southern hemisphere, we've got a lot more water than they do in the northern hemisphere. So this is why global warming at the moment is more extreme in the northern hemisphere than the southern hemisphere. We're putting the water in the southern hemisphere is managing to absorb a lot more of the heat with a very small change in temperature compared to the land in the northern hemisphere, which changes its temperature much more readily as you put heat into it. Okay, so let's consider the equation relating specific heat to change in temperature. The heat, which is the energy added to the object, is equal to the mass of the object times the specific heat of the object times the change in temperature of the object. So let's have a look at a couple of examples of how we could use this equation.
A wooden spoon has a mass of 100 grams. A stainless steel spoon has an equivalent mass. If 780 joules of heat energy is added to the spoons, what is the change in temperature of the spoons? We're told that the specific heat of wood is 1,700 joules per kilogram per Kelvin, and the specific heat of steel is 502 joules per kilogram per Kelvin. So the equation that we're going to have to use in this case is Q is equal to mc delta T, and what we're trying to find is this change in temperature. So let's rearrange it. The change in temperature is equal to Q over mc. Now in this question we're told that the heat added, Q, is equal to 780 joules, and the mass of the spoons is 100 grams, which is 0.100 kilograms. To get the mass into kilograms, we just divide by 1,000. And so the change in temperature is 780 over 0.100 times, for the wooden spoon, 1,700. And solving this on the calculator, we get 4.6 degrees C. So that's the change in temperature of the wooden spoon. The change in temperature of the steel spoon is equal to Q, which is 780 over mc, which is 0.100 times 502. And solving this one on the calculator, we get 15.6 degrees C. So you can see that the steel spoon has a much larger change in temperature than the wooden spoon, which is why it's a good idea to use wooden spoons to serve hot saucepans rather than steel spoons. Another question to try. How much energy do you need to add to raise 1.5 litres of water from 25 degrees Celsius to 100 degrees Celsius? If a kettle uses 1,500 watts of power, how long will this take? So that's a relatively low wattage for a kettle. So first of all, we need to work out how much energy is added. So to do that, we're going to have to use our formula Q is equal to mc delta T, where m is the mass, c is the specific heat, and delta T is the change in temperature. So the mass, we've got 1.5 litres of water. Now 1 litre of water weighs 1,000 grams. So this is 1.5 kilograms of water. The specific heat for water is 4,186 joules per kilogram per Kelvin, and the change in temperature is equal to the final temperature minus the initial temperature, which is equal to 100 degrees C minus 25 degrees C. So this is around about room temperature. So this gives us 75 degrees C is the change in temperature. And so the amount of heat we need to add is given by 1.5 times 4,186 times this change in temperature, the 75. And solving that on the calculator, we get 470,925 joules, which we can write as 471 kilojoules. We convert it to kilojoules by dividing by 1,000. Now what we need to do is work out how long it's going to take. So we know that power is equal to energy over time, and in this case we've got heat energy, so that's Q over time. So the time, just rearranging this equation, we can see that time will be Q over the power. So the amount of energy added is 470,925, and the power used is 1,500 watts. So solving this, we get 313.95, and that's in seconds. Now if we want to get the time in minutes, we have to do 313.95 divided by 60, and this gives us 5.23 minutes. So that's a relatively long time, but this is a relatively low wattage kettle, and 1.5 litres is quite a lot of water to put in the kettle. So that is a completely reasonable answer.